So next, let's do problem 39, where we have x squared plus y is less than 9. All right. So now, well, let's draw it like this. We'll isolate y. Okay. This is another way of saying y is no, not like that. That's another way of saying is y is less than 9 minus x squared, okay, minus x squared plus 9, okay, that would be the inequality. Now what we're going to do is first we'll graph the graph that's y equals to minus x squared plus 9. Then we'll figure out which part of it is less than and which part of it is bigger than, that sort of thing. So to graph this thing, we have first we have that's an upside down parabola, okay, a sad face, sad mouth of the sad face. So then, but when x is 0, y is equal to 9, so it starts up here. So the parabola is an upside down thing that goes something like this. Okay, a rough draft is all it takes, and that's all we need around for now. So when, and then you ask yourself, this is the y equals to the stuff. When is y less than? Most of the time, if you say y is less than, it will be under it. Okay, but to make sure, let's say right here, let's consider the origin where x is 0 and y is 0. So what happens when x is 0 then? At this point, if x is 0, and right here, okay, so y is also 0. So we have 0, and then this is 0, okay, plus 9. What's the relationship between 0 and 0 plus 9? That would be less than. So this entire region would be the answer to our question, and that's the end of the problem. Okay, so that's how we do this type of thing. So next, let's consider problem 41. We have x squared plus y is less than 1, and y is bigger than 2x. Now to do that, they also want us to label the points of intersection. Okay, let's label it if they want us to label it so badly. All right, so first, to label the point of intersection, what we're going to do is we're going to solve the equation x squared plus y equals to 1 and y equals to 2x. And once we solve it, then we'll find out where they intersect. And then that'll help us graph them and stuff. Okay, so let's do that. To find out the points of intersection, we have to solve these two equations together. So y is 2x, so stuff y equal to 2x right in here. Okay, then we get x squared plus y is 2x, so write down 2x, and then minus 1 equal to 0. Yeah, that is not looking good to me. So this is not looking like a lot of fun because there is no way we can factor it simply. Okay, we have to pull out the good old quadratic formula. So let's do that. The quadratic formula states that the root of a quadratic formula is minus b plus or minus square root of b squared minus 4ac divided, a is just 1, divided by 2a, which is just 2. All right, so that's our x, which once this part becomes 4 plus 4, right, which is 8. So it's equal to 2 plus square root of 8 divided by 2. And then we have to, the square root of 8 is the same as 2 times square root of 2, okay? Because you can factor 2 out of here, and the factor 4 out of here, and square root of 4 is 2. And then you have a 2 left. So together, then we get, so then x, this is a plus or minus situation. So x then equal to 1 plus or minus 2 times square root of 2. And those are two distinct values, at which point if x is this value, then y is equal to the other thing, which is 2 times that much. In other words, the two intersections are first 1 plus 2 times square root of 2 and comma and 2 twice that much. So is 2 plus 4 times square root of 2. That's one of the points. And then the other point is 1 minus 2 square root of 2. And then the other one is twice that much, which is 2 minus 4 square root of 2. So those are the 2 points of intersection. And with that, yeah. With that, then we can now graph this thing. The first equation is, let's see. To graph it accurately, we're going to have to figure out what these numbers are. And I'd rather not. This is a positive number. That's positive, sure. This is going to be a negative number, and so is that. Yeah. So what does that tell us? I'd rather just do this on the calculator. Okay, so let me do that. So I plotted it in the Desmos calculator, right? The one online. And as you can see, it turns out to be a parabola that looks like that. There's the one intersection is at a positive and positive value, the other x positive, y positive, the other intersection at x negative, y negative. So that's what the graph looks like. All right, so the next thing we need to do is we'll draw this graph, right about here. This is as good as any. I'll copy it something like this. Let's see, we have this thing, okay? And the parabola goes like that. And then the line goes something like this. All right, so then the next thing we look at is which part is bigger than or whatever. What happens is that to rewrite this thing, we would have to rewrite this inequality as y and put x on the other side, okay? So then we have y less than 1 minus x squared. So as a result, being the positive y is on the less than side, we can check 0, 0. If we have 0, y is 0 down here, okay? Here's the graph. Down here, if y is 0 and x is 0, what does the inequality stand? That will be 1 minus. So the inequality goes like this. So then this is this part checks out. See, that is what's under fits the idea the y value, the equation will hold out as y is less than 1 minus x squared. Therefore, for the parabola, this equation satisfies on all this stuff here. This goes all the way there. And then y bigger than 2x is anything that's above the line. Above means on top, okay? And then so then this part, the intersection then is what these two are talking about. Of course, I should also mention that it does matter that these two things are not, being that they are strictly bigger than and strictly bigger than, then the drawing, theoretically, it should be dotted lines, okay? That just means the line themselves, which means equal to, are not included because it's strictly bigger than or less than in both cases. Yeah, so that's that. Next, let's do problem 46, where we have y is bigger than e to the power x, and y is less than natural log of x plus 5. Now what are we doing? Graph. All right, so to graph this thing, we have, first we need to know what y equal to e to the power x looks like. So for y equal to e to the power x, you might remember that it looks something like this, okay? The exponential growth graph looks something like that. If you don't remember that, please type it, find it somewhere or something. Then this is what it looks like. And then similarly, the natural log graph, y equal to the natural log of x, looks like something like this. It goes like this. It goes through 1, 0, and then takes a dive and doesn't ever cross here. So that's that. Yeah, this also goes towards 0, but doesn't cross because this is a vertical asymptote and this is a horizontal asymptote. So then, then from this is also already similar to that. Now this one is at this value plus 5, so we need to lift it up 5 units, and so this is the same thing, okay? And we'll draw it over here. So this is 1, 0, and we'll lift this thing up 5 units. So pretend that is the new x-axis, and we'll draw the draw this thing something like that. All right. So this graph here is y equal to natural log of x plus 5. Okay, the one that goes this way. All right. So then what we need is y need to be bigger than e to the power x. So here is y to the e to the power x. If it's bigger than, then it's the area on top. Okay. And then the other one, y is less than this stuff, so that is the area under it. So this part. So the intersection of that football-shaped object would be the answer to our question of problem 46. Now let me look at the answer. Nope, there is problem 46 doesn't have an answer, which is okay. But that is, if you type these two graphs into the decimals calculator, it will give you a more precise graph, but it should look something like this. Okay, that should be the proper answer. All right, so next. All right, next let's consider problem 47. We have y less than equal to negative log of x. Well, first, y equals to log of x look like this. Okay, this is a natural log, but they all look about the same. Okay, something like that. And so this is negative, but this one's negative. Negative means you flip it around. What used to be positive is now down here. So imagine the graph being flipped like this. Okay, and so then the graph, then the new graph will look something like it goes something like that. It goes to infinity. This is a vertical asymptote, and it doesn't go up, and that is giving off the wrong impression. This thing goes down. Okay, basically the mirror, what used to be positive is now negative. So the mirror image of the other thing. All right, so this is y equal to, let's see, let me hold the marker properly. Y equal to minus log x. Okay, log x means base 10. And then the other one, e to the power x, is the same as the other one. So we have this thing right here. Okay, it goes through 1 and goes that way. All right, so then first we need y is less than this thing, so the graph is under it. Okay, whatever's the under part, and so on. But remember, this graph doesn't ever cross the y-axis. It stops along the y-axis. It doesn't go to the other side because this function is not defined on the negative side. Okay, and the logarithm is not defined when x is negative. So in the meantime, y less than e to the power x will be back here. Y is less than e to the power x. Right, and but that's defined everywhere. So what is the intersection? The intersection then is this part right here, which I will draw it with a different colored marker to emphasize the point. So the intersection of these two things is basically this thing, this weird shaped object that goes down infinitely, something like that. Okay, that is also what the book says. Anyway, so that is the answer to problem 47. Is yeah. Okay, next let's do problem 49. Now we have 6 over x squared minus 1 over y squared equals to 8. 1 over x squared minus 6 over y squared equals to 1 over 8. How cute. I mean, look at how symmetrical this thing is. It's 6 over x squared, 1 over x squared. 1 over y squared, 6 over y squared. 8, 1 over 8. Does that mean anything? Not that I know of right now, but it's cute anyway. Okay. So let's solve this thing as in, we are going to solve it like, let me think, like this. Like, yeah, we'll let a equals to 1 over x squared. Okay, so we'll set up a system like this. A equals to 1 over x squared, and then b equals to 1 over y squared. So then we'll rewrite this thing. Once we figure out what a and b are, then we can figure out what x and y are easily enough. So this becomes 6a minus 1b, which is just b, equals to 8. And then this is a minus 6b, that equals to 1 over 8. Okay, and then we are going to, that is not making things easy for us. Okay, so this is equation 1, and we'll call this equation 2, and we'll take equation 2 and multiply it by -6 to get rid of the a's. Okay, so let's take equation 2 and multiply it by -6. That becomes minus 6a plus 36b, and which equals to 6 over 8, which is the same as 3 over 4. And then this will be called equation 3. And let's add equation 3 to equation 1, as our plan is to get rid of a. So to do that, let's write this down. Equation 1 plus 3. That will yield us, the a's disappear. Plus 36 minus 1, that's 35b. Oops. 35b. Let's see. Okay. 35b equals to 8 3/4. Okay, we'll write it this way for now. 8 3/4. Yeah, I think so. All right. So then b then equals to, let's pull out the calculator. Let's see what the calculator says. And I'll stand over here. We have, let's see, I'm not sure how to type in 8 3/4, so I'm just going to type in parentheses, 8 plus 3 divided by 4. Okay, let's call that 8 3/4. And divided by 35, that gives us something, 1/4. How cute. So b equals to 1/4. b is equal to 1/4. All right, and then a, will, from equation 2, we get a equals to, move the minus 6b on the other side, 1/8 plus 6b. Right? All right. So then, let's see. I'll think about that later. So again, let's type in, so to calculate a, I'll do 1 divided by 8 plus 6 times, what was b again? 1/4. So that means 6 divided by 4. Okay, divided by 4 is the same as times 1/4. Okay, that should do it. That's 13 over 8. A is 13 over 8. I guess. All right. Let me write that down, and then I'll check to see if I messed something up. That seems to be 13 over 8. And let me check this stuff. So anyway, I found out where I messed up. Look at it right here. Okay, I said equation 2 times minus 6. So it's minus 6a, that's good, plus 36b, that's good, and then I passed out right here. See, times minus 6 should be minus 6 over 8, or minus 3/4. That is going to, remember the previous answer of beautiful little 1/4? That would be so nice, wouldn't it? Yeah, that's gone. Okay, we don't have anything beautiful to show for it. So this is negative, which means now we're going to do equation 1 plus equation 3, which gives us 35b, what? No, 1 and 3. All right, so it's minus and this, so it's 35b, and then it becomes 8 minus 3/4. So this is 8 minus 3/4, and that'd be like 7 1/4 or something. So that equals to 7 1/4, and so then b then equal to let's pull out the calculator again, and I'm going to do this again. All right. So b then equal to 7. So I'll do 7 plus 1 divided by 4. And then divided by 35. That's b. Okay. That's 29 over 140. I will check this first. All right, so let me write this down. B equals to 29 over 140. We'll deal with that later. Okay, so then A then equal to 1/8 plus 6 times B, and that would be equal to, let's see. So we will have 1 divided by 8 plus 6 times 29 divided by 140. That would be equal to 383 over 280. Like I said, this is not going to look that as pretty as I hoped. 383 divided by 280. Great. All right. So that is that's our partial answer. We have originally said that a equals to x squared. So x then is equal to plus or minus square root of a. Okay, and that is equal to what was a again? That thing. Okay. So no, it's not plus or minus square root of a. I said that wrong. It's plus or minus 1 over square root of a. That is we have to do the, so 1 over square root of a. And that 1 over square root of a is the square root of, we flip this thing around. That's square root of 280 divided by 383. That's what that is, okay? So that's x. And then y will be equal to plus or minus square root of b, 1 over square root of b, 1 over square root of b, and that is that would be equals to the square root of, flip that around, that's 140 divided by 29. All right, so that means 8. We have the solution then has 4 points, plus or minus, okay? And I'm not going to write it all out, but you get the idea is that each, that is the solution, with the 4 points consists of positive this, comma positive this, comma negative this, and then negative this, comma positive this, and then negative this, and comma negative this. So that's the 4 points which are shown in your calculator, I believe. That doesn't look exactly like the answer, but I think that's because let me check. Okay, yeah, because if you factor out 4 here, that will become 70. Take it out, it becomes 2, and then this one 70. 70. Let's see. Yeah, if you factor out, you can factor out. Can you factor 4 here? Yeah, I think so. Then you have 2 times 35. So this is identical to the answer in the back of the book, except that you will have 4 combinations. That you have 4 combinations of these values, which will end up being the plus, and then plus, minus, and minus, plus, and minus, minus. That's how that works out. Okay, your 4 answers of these objects, which I'm not going to work on. So that is so that's problem 49. All right, next, let's consider problem 53. We have x times y is less than 1. Let's graph that one first. So if xy is less than 1, what is that? Let's consider the equation xy equal to 1. Okay, so if xy equals to 1, then or put it another way, y equals to 1 over x. That would be the equation that looks like this. Okay, this is one of the graphs that you're supposed to memorize. Y equal to 1 over x. The other side goes like this. Okay, and then when is it less than 1? Well, at 0, 0, 0 times 0 is less than 1. So any area in between here should work. And then if it's out here or down there, it would not be less than 1. So that is that graph. Now the next graph we need to consider is y bigger than square root of x. Now to do that, what is the square root of x? Is the square root of x goes like this, like that. Okay, it only has one branch because it's not defined when x is negative. We do not consider complex numbers right now. So this is only good for this part. Now, when you consider these two graphs together, then by the way, what is y bigger than square root of x? Then it would be bigger than would be on top. So it's this area. Okay, and right. So then we need these two conditions together. And if they're together, then they would be, let's see, we'll draw that here, something like this. And so what is common for both? That would be this area right here. Okay, and that should be it. And the boundary is dotted because we don't want any equal to. We only want strictly less than and bigger than there. So let's see. Yeah, so the area that is in common would be this area, this thing right here, or if I draw it with a green marker to mark the boundary, though the boundary is not included, so all of this stuff that I mark green, that should be it. Anyway, so yeah, the answer in the book doesn't even give us a graph, which they should have, because they said something about graphing, right? It says to graph it. But anyway, that should be the answer to problem 53. I suppose I should mention that as long as x equal to 0, this line is actually included as part of the solution set. That is, this part is included as long as y is bigger than 0. And although that's just a tiny little detail, I'm not sure if it's really that much worth mentioning. But I suppose I should say that at least. So next, let's do problem 55. Two numbers, we'll call it x and y. They add up to be 300. So the first situation is pretty easy. X plus y is 300. All right. And then one number is twice the square of the other number. So let's say x equals to 2 times y squared. Okay. Does that sound like twice the square of the other number? One number is twice the square of the other number. Does that look right? Yeah? It seems okay to me, so let's go with that. So then we'll plug x right in here, okay? And so then becomes 2y squared plus y, and then we'll move the 300 over, minus 300, and that equals to 0. And then, and at this point, instead of trying to do that trick, we're just going to do the quadratic formula. So then y equals to minus 1 plus or minus square root of 1 squared minus 4 times 2 times negative 300, which is good because we have a minus sign here. So another minus sign will keep it positive, and all divided by 4. And that would be, so y equals to minus 1, minus 1 y equals to minus 1 plus or minus square root of, what is that? That's 8 times 3 is 24, right? 2400 plus 1. So 2400 and plus 1, and then divided by 4. So that is y. Yeah, okay. So let's see if that's equal to anything we recognize. To do that, let me find my calculator. So first, let's figure out what the square root of 2401 is. First, let me turn on my calculator. then I'll type in square root 2401, and that equals to 49. Great. So that helps, okay? And so that is only this, instead of we get stuck with some super ugly number, we at least get a whole number to show for it. So minus 1 plus or minus 49 divided by 4. So minus 1 plus 49, that's 48, divided by 4 is 12. So y equal to 12. That's the first option. Minus 1 minus 49, that would be minus, that's minus 50, right? That would be a negative number, so that's rejected, because we are only thinking about positive numbers right now, I think. Are we thinking about only positive numbers? It doesn't really say that, does it? Let me think. Well, we'll write it down anyway, okay? So then we have that would be minus 50 over 4, or say minus 25 over 2. So that would be the other number. Of course, the 12 is our favorite, because who wants to deal with whatever that is? And then, so x, if y is 12, then x is equal to 2 times 12 squared times 12 squared. 12 squared is 144, so twice of that is 288. And so that is one pair of answer right here, these two, okay? And y is 12, while x is 288. And then, of course, x plus y, if that is true, x plus y will be 300. Now, if y is minus 25 over 2, then x will be 2 times y squared, which is okay. Let me see how that goes. So y is negative 25 over 2, then x equals to 2 times 25 over 2 minus, but it's squared, so the minus sign doesn't matter. What is that? Let's figure out what that is. Okay, that sounds, well, it doesn't matter what it sounds. Let's just multiply it. Being that we're squaring it, we don't care about the negative sign. So we'll do 2 times 25 squared. Where's my squared? Right here. 25 squared. No, sorry. Delete. Okay, 2 times 25 divided by 2, and then squared. That's better. And then squared, right? And 2 times, yeah. Okay, that would be equal to 625 over 2. Okay, that looks about right. So x will be 625 over 2. Wrong marker. Where's my marker? Here it is. Okay, so x equal to 625 positive. Let's see, 625 over 2. Now, if that's the case, x plus y is still 300, so it's okay. Yeah, so both sets of answers are okay. Now, the word number, a lot of times, if a question asks 2 numbers, they mean 2 positive numbers. In fact, 2 positive whole numbers, that is natural numbers. So no, most of the time we don't consider the other option, but it depends on what they mean by number. If it's just any number, right, then the other option is also acceptable. That is, this is the other answer. But the book did not accept this answer, okay? The book just have us accept the easy one, which is fine also. So that should mark the end of this section.